All right, Unit 8, Lesson 2, going to be focusing on parallelograms. So the big question, what makes a parallelogram a parallelogram? And you actually have all of these characteristics. So opposite sides are parallel. So that means that this line right here is parallel to this line, and these two lines are parallel to each other as well. Opposite sides are congruent. That means that this side is the same length as this side, and this side is the same length as this side. Opposite angles are congruent. That means that, I don't like yellow. Let's see here. This angle is congruent to this angle, and this angle is congruent to this angle. Consecutive interior angles supplementary. Again, Mr. Larson prefers the word same side interior angles. So if you want to, let's see if we can just... It's the same thing, different terminology. Same side interior angles are supplementary. Do we remember this word? Supplementary means adds up to 180 degrees. So if I just go through and label it A, B, C, D, that means that angle A plus angle B equals 180 degrees. It would also mean that angle A plus angle D would equal 180 degrees. Because again, D and B are the same thing. And then the last bit is the diagonals intersect at the midpoint. So again, if I were to draw diagonals here and diagonals here, this would give me the midpoint. So let's use our properties of rectangles, parallelograms, to find FG and the measure of angle G. So because I know that opposite sides are congruent, if this side is 8, this side is 8. So FG is going to equal 8. And because I know that opposite angles are congruent, if angle E is 60 degrees, then the measure of angle G is also going to be 60 degrees. This one's a little bit trickier. If I'm looking for X, okay, I know that angle J and angle L are congruent, so now I just have to set them equal to each other. So X in this case is going to equal 25 degrees. And then kind of similarly, I know that KJ and LM are congruent, so I'm going to set them equal to each other. And if I subtract 3, I get 15. Find the properties indicated, measure in parallelogram JKLM. So NM, all right. If these are diagonals and they're the midpoint, that means that from K to N, it's 2. Well, that also means from N to M, it's going to equal 2 as well, because it's that point N is cutting it in half. So if I wanted to find KM, well, I'd have to do little segment plus little segment equals big segment, which would give me 4. Looking at JML. So again, this is going to be this kind of larger angle right here. And so I see, hey, angle KJM is 110, and I know that same side interior angles are supplementary. So that means they're going to add up to 180. So I'm going to take 110 plus whatever this unknown angle is. I'm not sure what the angle is, but I know it's going to equal 180. So this unknown angle, JML, is going to equal 70 degrees. So JML is 70 degrees, which helps me figure out the measure of angle KML. So again, KML. Now I know that this whole big angle right here, this whole thing, we just found to be 70 degrees. So think about what Mr. Larson always says. Little angle plus little angle equals big angle. I know one of my little angles is 30 degrees. I don't know what the other little angle is, but I know the total is 70. Well, that means that it's going to be 40 degrees. So this equals 40 degrees. Last problem, the diagonals of LMNO, parallelogram LMNO, intersect at point P. What are the coordinates of P? So again, I look at my scale, this is 1, 2, 3, 4, and we got 1, 2, 3, 4. Let's see here, 5, 6, 7. I'm gonna call that 3.5 and 2. X is 3.5, Y is 2. 3.5 is the same thing as 7 over 2. So if X is 7 over 2, Y has to be positive 2. So I believe that that answer is A.